Hello everyone, SAP495 and Structural Club. Okay, this is another example of Rhino grasshopper modeling and conversion to the SAP and SAP initial analysis. So I'm going to walk you through with this model. This example, I'm going to use a volt structure, so I kind of create some simple script. Okay, so let's go here. So what I'm gonna do is show you, let me turn up. Briefly, I'm gonna talk about it and turn up so that you could see clearly how can I start it. So basically I define exit plane, so vertical plane, exit plane I'm gonna use for drawing the arch. So I'm gonna turn on the arch. So arch, this component, all right, you require the radius. So I set it up using Gimple 2. I assign the 3 variables, right? So that it has a radius. It can be used as a radius and 3 radius. Now each 3 one I'm gonna copy to the y direction, right? Because you see the x, y, z plane coordinates, and I copy. I'm gonna turn up and turn on. So I copy those 3 arcs in various y directions. So if you move this, basically you can move this, right? Right? And also if you want to change this radius, you could do that right away, right? So this is really cool stuff, iterative design kind of parametric study for the geometry, I think also structural. This is really cool to learn. So once you set this geometry you want to using raft, so you can generate the surface by using 3 line, right? See that how easy it's quick. So I'm gonna use this. So based upon this is surface. There are the 3. This is lunchbox plugin created by Tantanto Massetti. I'm using this plugin. Based upon the surface, it can create some this grid structural pattern and race, and also expressing. So these cases I'm going to show you 2 example. So first one, okay, I can use this X bracing, but I think this is too much, right? So, but we can try. And also this is grid. Basically I'm gonna turn off, and I'm gonna turn on this. So this is just XY grid structure. Let's try the first grid structure so that I can I'm gonna convert. Let me see. Maybe you know what? I can bake together and import to the SAP together, so I can show you both comparisons. So first one, so I need to bake, means obviously I need this geometry. Right click and bake. So this into the layer 1, right? So basically I have a line here. I'm using fit, so you need to follow along. And also this, because I'm gonna use some, I need some the surface in order to assign the area, the wind load, for also estimation for our cladding weight dead load. So this is the sum of the 2 plugins provided by the Weaverbird. You should download and install this all. I can give you so that you can just use it right away. So I'm gonna bake this one, right, to layer 2 as well. So this is the complete. I'm gonna, let me just select and move this. So if you see this in the rendering, right, so I have a line, right, and also I have a surface. So this is ready. All right, okay, so now I'm gonna this hide. I'm gonna do the same thing for using expressing. So I'm gonna bake this one to layer 3. So I have all line elements, right? Then I'm gonna also create and bake to layer 4. So I'm gonna turn up this. So basically I'm gonna have both geometry ready, line with the surface, right? So now this is power of Rhino and Grasshopper. I know eventually real structure we may have to really kind of work it out and coordinate and some more play with the parameters. But this is just in general simple, the powerful Rhino and Grasshopper parametric tool I want you to study for your future design works, I think, right? It's part of good the workflow. So I'm gonna close this. I'm gonna zoom in. So I'm gonna bring this to geometry to the SAP. In order to do that, I have to select and export to using IGS form. So export to SAP. So I'm gonna export to IGS form file, right? I export. So now I'm gonna open the SAP, but I need to make sure this is a fit, same unit. I'm gonna go and import IGS file. And then I'm gonna click that board set, yeah, file. I'm gonna bring line and the surface together. All right, so see that all reference geometry I brought in, and there is actually something I wish I could do it, but separately, because something in order to assign the section property I need to select, but there are too many elements, so there's sometimes it's cumbersome to click and assign the section properties. So there is something maybe for like this, if you have a bunch of primary elements and diagonal, I maybe I could have kind of export separately, so diagonal members and primary member. So once I import it, I can easily grab and export, bring this separate at the time and assign the section property more easily. Maybe I can try, because I need eventually have to assign the section properties. So let me see. So this one, no, actually, for example, for now, leave it. I will just walk you through first. So now what I'm gonna do, so I'm gonna put this one at the bottom. This doesn't usually on this. Correct. I need to turn on the nodes. Okay, do I have a 0, 0? Okay, this might be 0, 0. Okay, so at the bottom, I need to assign, I'm gonna assign the boundary condition restraint pin, right? You see now all the pink boundary conditions, and I'm gonna first of all bring my new material property, since I'm gonna use a tube. So I'm gonna use A500 grade B 46K size steel, and I'm gonna use section property from the data. I'm gonna use a tube. Eventually, let me try using ASAC 14 some data bank. You know what? So this one, I'll just choose one 8x4, 8x8, 8x4. So I'm gonna choose 8x4 quarter inches, but I'm gonna choose material, right, for HSS. So I just brought in, I'm gonna select all the line elements assigned to HSS 8x4. Okay, so I assign it. If you want to double check, you maybe can try somehow turn on the extrusion and see the member is assigned, because I have a surface. This one doesn't click. And you can turn up and you can see this. Oh, did I? Seems like I missed the line element here. Oh, I didn't. Maybe I could use this. This is also maybe interesting, but I don't have this arch member here. So I missed some arch member for this model. All right, so for in order to expedite this explanation, I already fixed it. I brought this also primary element, right? It's a line work. Just export and import. Something's kind of straightforward. Nothing actually is hard. So where we are is we have all the line elements set and area elements there. And I turn off, but I turn on that again. So all the section property I assigned equally use one section, but eventually diagonal member should be smaller. But for simply just expedite this procedure in order to explain, I just use the one same size for diagonal here as well as the primary element. All right, so see that all this green is boundary condition, pin connection. And then I'm gonna just check and open, then create the load cases. Default, we have a self-fade, but I'm gonna also create the win load. So I'm gonna create the win, choose then win. I'm gonna choose SAP716, right? But we're not using SAP to generate the win load, which we're gonna just assign win pressure manually. So I'm gonna select all the area and assign. I think this is located in X direction. Let me see. So we try to assign the loading in X direction, right? So assign and area load uniform shell in the load cases, but this case is global X direction but X projected. So I'm gonna assign 30 psi wind pressure on the surface for now for this example. Somehow the boundary condition was turned off. This really kind of annoying. This train I turn on. All right, so this model is ready to run. I'm gonna run it and run. Club. I'm gonna save it. Okay. Oh, it showed some. I'm gonna show you deformation first. Self-fade deflection and obviously vertical Z deformation. I'm gonna turn off. Let me see. Okay, it shows some color coded. And this time deflection, I'm gonna use inches. So you see that the deflection is 0.053 versus 0.053. Oh, this is self-fade deflection, so probably small. You don't have to worry about the number yet. Just I wanna encourage to understand overall workflow. So if you now interest while you're finished the analysis, just try to understand how this building is behave, structure is behave. Right. This is self-fade deflection. Now I'm gonna show you the axial force. Right, axial force due to the self-fade deadlock. You see the compression tension. Compression in color, red color. The blue is tension. Somehow originally yellow was the tension, but they set this blue for some reason. But at least you want aware. See that if you click this, you see the minus, right? And blue is positive. So this is an example of two models axial force diagram under the self-weight. Now let's check this, the deformation under the wind loads, but this is deflection is X direction, right? Because the wind is assigned in X direction. So I'm gonna rotate like this and put the animation. So wind is blowing in X direction and push the building in X and Y. This is color coded, so same thing. This checkbox is again. I'm gonna turn up this shell, and even I think this is usually I like it most, so that you can see and our structure and their performance under wind load. Also, you can check the axial force diagram, internal force due to the wind. So basically what you're doing is really you keep repeating this procedure, right? You need to create the geometry using other tool, efficient tool. That's why you need to learn Rhino Grasshopper. I encourage you to learn at least the tool. Otherwise, old school, we're using AutoCAD and draw in 2D or copy and adjust it, and you import and export and import manually, then it take a while. But this is Rhino Grasshopper is really give us another level of efficiency. So I want you to study and also watch and follow along this tutorial a couple of times, similar way, and then you get there, sooner or later. Okay. So here I'm gonna just deflection. Yep, I like this form. Right, I'm gonna just stop here and upload it to YouTube. I hope you guys watching and learning practice. All right.